Hello everyone, today we will be talking about how local soil conditions such as the soil properties at a site can amplify or de-amplify seismic waves from earthquakes.
You probably know that the intensity of ground shaking depends on the earthquake magnitude, or the size. But did you know that the soil conditions can also have a significant impact on how intense and damaging an earthquake ground motion may be? Around 500,000 earthquakes occur per year, but only around 20% are felt by humans, and about 100 cause damage per year.
There are three main types of effects that earthquake engineers and seismologists focus on: source, path, and site effects. Source effects are represented by the magnitude, location, depth, and fall type of the earthquake. Path effects refer to the propagation of the seismic waves from the source to the bedrock beneath the site.
And site effects are the effects of the sediments below the ground surface down to the bedrock, involving the geology, topography, and soil properties. Different types of soils can amplify or de-amplify seismic waves from earthquakes. The amount of amplification can depend on the stiffness of the soil, which is measured by its shear wave velocity. Shear waves generated by the earthquake pass through stiffer soils faster than through softer soils, and thus stiffer soils have a higher shear wave velocity.
Here you can see a demonstration using two different jello columns that represent a less stiff soil column with a low VS value and a stiffer soil column with a higher VS value. The building on the top of the lower VS column experiences larger displacement from the motion at the base of the columns.
A real-life example of this phenomenon was observed in the 1985 Mexico City earthquake. Even though the epicenter of the earthquake was roughly 400 kilometers away from Mexico City, there were still significant damages caused by the amplification of the ground motions due to the local soil conditions.
Mexico City is on top of a shallow deposit of softer soils that are underlain by stiff rock. The ground motions at the top of the rock were amplified as they traveled through the softer soils below Mexico City, increasing the peak ground oscillation and the duration of the motions, which caused more damage in Mexico City than other locations that were actually closer to the earthquake's epicenter. This goes to show that side effects are a critical part of determining seismic hazard and must be considered within geotechnical engineering design in at-risk regions.
Thank you for watching and enjoy Geo-Congress.